Okay. Let's try this again. All right.
Thank you.
This better?
I'm not hearing an echo. Are you?
Okay. All right. Okay.
Okay, here I go again. My name is Nasser Jivanji, and I'm a member of Los Angeles Astronomical Society for the last 6 or 7 years, I think. I joined in 2016. And a couple of years after joining, I started astrophotography. And these days, I mostly do it from my backyard. Because of COVID, didn't go to Lockwood for last 2-3 years. So I started doing narrowband for my backyard. And this is a lot of light pollution here, but still we can manage it through narrowband filters and long exposures, multiple nights. And my setup is 80 millimeter stellar view and 150 millimeter Explorer scientific telescope. And I got GM45G mount, which is a newer mount. And most of my imaging is done through 1600 camera and ZWO narrowband filters and RGB. My guide camera is ZWO 120 and 200 millimeter focal length telescope. And I use Pixel Sight and iPhotos from Mac, usually for my editing. And I'll go through some different categories. So solar systems, usually I don't do planets, but this year there was a big planetary lineup. I'm sure you all guys tried to take photos, and I did it. This is from Lockwood, actually, not my backyard. And you can almost see Mercury, but right now, if I zoom in, you can see Mercury, but I have to stitch together all these photographs. Amazing, you can see almost all the planets. Even Pluto is there, but obviously not visible. Here's another one, a little bit longer exposure, so you can better see some of the planets here. And you can see this is Lockwood early morning. It was, I think, in June or July this year. And also, finally, this year we got some sunspots, because I know last couple of years it was pretty dry. So that's about it for my solar system imaging. But I mostly do galaxies and nebulas and some clusters. And this is one of my favorite objects. Since I got a new telescope, I tried this again. And within a couple of hours, I got a decent image, just RGB, no luminance. And you can even see some 2 tiny galaxies in there too. One of the tiny ones, this one you can see, this is about 500 million light years away.
Is that some nebulosity by the galaxies?
Excuse me?
Is that some nebulosity, the sort of the reddish, right between the 2 galaxies?
Oh, this reddish? Yeah, I don't know. Yeah, that's probably just noise, I think. Yeah. And this is another favorite object to image, just 4 hours is this H. I did it in, try to do in narrowband, just H alpha, S2 and blue filters to get as much as this bluish thing. But yeah, this is another pleasing object to take from your backyard. Now, galaxies are difficult from backyard, but this time I just did long exposures, 15, 20, 30 hours, multiple nights, and you can get some decent image. This is one of my best image of M33. All the red stuff is H alpha high emission nebulas in this, all these bluish are hot stars around it. And of course, in the middle is mostly old stars. It's a decent job, but I think it needs a little bit more. It's a little bit more noisy than I would like to. Yeah. I think I need to add luminance to it because I didn't add luminance. For some reason, somehow when I try to add luminance, it becomes less detailed. So I must be doing something wrong here.
Nasir, did you shoot that one with your new 150 or is that with your?
This is yeah, this is with 150 millimeter. Yeah. Because I did with last year, I actually did the same thing with my 80 millimeter, and definitely I have much better results, much more detail here than last 80 millimeter. Here's another interesting galaxy 7331, which is very similar to like our own galaxy, they say. And this one is it's pretty far, 47 million light years. And there are some 4 tiny far off galaxies which are over 300 million light years. One of them, this one is about 430 million light years away. And this is only 5 hours of RGB. And I'm sure you can get even better if I do some more imaging with luminance and longer hours. But it's amazing that such a far off galaxies, you can see all these dust lanes. It's an amazing galaxy. This is my longest exposure ever, 40 hours. Wow. And yeah, 40 hours, you can pretty much get rid of all the noise, I guess.
It's beautiful.
But
Nader.
still, thank you.
This cigar looks amazing. You're gonna have to work on that one by itself with the new scope.
Yeah, this was done with 80 millimeter, not with the new scope. Yeah, and with 80
Spectacular.
millimeters, yeah.
The
I
cigar
think it was.
with your new scope at 150, the cigar will be full frame and that will be amazing.
Yeah, that's what I want to try next time. Because this was like almost a couple of months of project. This one, of course, needs more work. I think this is a beautiful galaxy. All the arms are visible, but it's only, I'm not sure how long. This is probably under 7-8 hours of total exposure. I'm not sure exactly how much. But this one, I need to work on more, get some more data. Hopefully next year it'll be much better. This one too, it's a pretty decent result from backyard. And but I think this needs more work on the colors. The colors not quite right because I only got RG, no blue in this. H alpha RG, there was no blue filter. So, but I like all these spirals. It came out pretty nice. Needle galaxy, 15 hours, but all you get is nice, decent dust lanes in the middle. Otherwise, it's pretty interesting. Yeah, this is a Mercurian chain in Virgo, galaxy cluster, M87 right at the bottom. That's where the black hole was imaged. I like it, but I think I need more work on this to get some good colors. The colors are not quite right.
Is that nebulosity in the middle of the image?
In the middle here? No, I think this is just my no, never. This is my dust modes. I think the flats didn't come out quite right, so it didn't take out this. But you see this? This is a dust spot. Yeah.
What is the
But-
ratio of how much time you capture versus how much time you spend in front of the computer to process?
Actually, processing is much more difficult. In some cases, it can take much. I mean, obviously, the time I spent on imaging, 18 hours and all that, 20 hours, 40 hours, is just time. I mean, I'm not, that's much longer time. I don't spend that much time on processing. But again, imaging is done remotely. I do it remotely. I set it up all night. I go to bed in the morning. I just collect the data. But then actual processing can take, depending upon the object, if they are like especially galaxies and all that, it takes a lot of time to take out all the noise and get the right colors. So it can take a whole day sometimes just on one object.
So the most you spend is probably about 24 hours, you would guess?
I would think so.
Okay, thank you.
But again, processing is difficult. I would say imaging is easy actually. Processing is hard. To get really good results, pixel sight is a complicated software, and to really get the full benefit of it, you have to study a lot. There's a lot of learning curve on it. And yeah, I'm still learning it. I've been using it for 3-4 years, but there's still a lot of things I don't do. Okay, so okay, let's go to the next image here. Oh yeah. And this is the first time I actually imaged a supernova. I don't know if you guys remember last year, there was a supernova discovered in a galaxy by an amateur astronomer, I think in Japan, in 4647 NGC 4647. This is the this big one is M60. This is a tiny galaxy, and that's a supernova. And actually, I tried to get this image again after like a couple of months to see if it has dimmed, and it had not dimmed even in like a couple of months later. But then I think I will try to image it again this year when it comes back into the view and see if it is still there. I'm sure it's not there anymore, but I don't have the comparison here, before and after kind of a thing. But I was amazed that actually I was able to image a supernova. That's the first time. Okay, nebulas are the best, are the most, objects that you can easily take from your backyard using narrowband, high emission. H alpha, you can get pretty good results. You don't need to go to backyard or dark mountains or dark sites. And this is 32 hours elephant trunk. And the colors are not the normal color, like it is Hubble palette. So it's a different color scheme. This is a wide angle view of the same nebula, a lot of nebulosity. Just 7 hours of H alpha. Another pretty one, favorite objects, 4 hours. Here's a different color scheme, Hubble palette color scheme. You see little different details in here. Cone nebula. Yes, this one has mostly H alpha in this. S2O3, there's not much. So that's why it's more like monochrome almost. Doesn't have too much colors in it. I think the stars are too much bloated here. California Nebula is a good one. I've imaged it with my 80 millimeter. This is the one with 150, which has got, so can't image the whole object. So it's about 80% of that, but got much more details here than my 80 millimeter. And again, a single color here. H alpha. This one, I've imaged it many times with this. First time I actually got a pretty decent transparent, this nebulosity around it, the bluish. Looks pretty nice. But actually, this was imaged without the blue filter. But I managed to get the blue color with H alpha, green, and S2 filter. Eagle, Nebula. Again, Hubble palette color scheme. And I tried to get this Pillars of Creation. Not bad, actually. From a backyard. I mean, I know you can't compare this with James Webb. Again, this one is also pretty bright nebula, North American, but you need long exposure, 12 hours. This one also done with my bigger refractor.
And that's there. 1.5 minutes left.
Okay, Thor Nebula. I have to do more on this, the colors. The Crab Nebula. I'm going to move fast now. Swan. With Hubble palette color scheme. One of my favorites, Rosette. Every year I take it. This is just H alpha in regular colors. Narrowband only, no RGB. Another favorite one. And the best one is this. I've taken this a zillion times ever since you start astrophotography. This is the first object you take. And obviously I've come a long way. This is only 1 hour of exposure and minimum processing. I've taken much more images and I have to process doing HDR to bring out the trapezium in it. But this is just a minimal half an hour of processing and 1 hour of exposure. And I got decent results. This is one of my best and prettiest image ever for M42. So that's it. Thank you. If you have any other questions, yeah, put it in a chat or email me, or yeah, if you have time, you can ask me now. But I guess I'm running out of time.
All right, thank you. We can circle back after all the presentations as well.
Okay.
Okay, so next
you.
is Jeff. So his title is Shot on iPhone. And so his abstract is, I was in Zion National Park and decided to try my hand at astrophotography. With just an iPhone, I was able to capture stunning images of Andromeda, very much by accident, which I would love to share with your group. Edwin Hubble, eat your heart out. Okay, Jeff, go ahead.
First of all, Nasir, that was incredible. So this is going to be the polar. This is going to be the absolute polar opposite of that. This is the point and shoot version of astrophotography. Can everybody see my screen here?
Yes.
Yes, we can see it.
Okay. Yeah. So I am very much an amateur astrophotographer. I was in Zion. It was, obviously a gorgeous dark night. Very different from the typical night here in LA. And I figured, hey, why don't I try this night mode thing on iPhone? So just for anyone who doesn't know, iPhones can do a long exposure. And I didn't realize at the time that you can go all the way up to 30 seconds. So I kind of put the phone down on my car, pointed up at the stars, just to keep it, the car was parked, just to keep it still. And the first image that came back was this, which was, it definitely blew my mind. And I was looking at it and I said, if I didn't know any better, I would think that was Andromeda right there. Cause I think I'm just sort of ignorant about all this. And I didn't realize that you could actually just see something that was 2.5 million light years away with an iPhone. So sure enough, I double checked and it's, right in the place that Andromeda is. So that is Andromeda. And here's a zoomed in version of it. And again, this is just with a 30-second exposure, just, point and shoot with your iPhone. I even did a little bit of annotation, to make sure that it was Andromeda. Sure enough, it was not just something that got in the way of some French guy who was looking at comets. So I took a few more. My friends really wanted to see if I could do the Milky Way. I was with a couple friends, so got some nice ones of the Milky Way. This one turned out blue. To this day, I have absolutely no idea how it did that, but I thought it was really pretty and put it on Instagram. And it was a big hit. And that was actually, so then I went home and I actually went up to Oakland to visit my parents in the Bay Area. And I thought, would this work? Obviously, this is Zion we're talking about here. Would this work in a more populated area? And it actually did. This, you can't really tell from this, but this is Andromeda, this little white thing there. So it was cool that you could even see it. Obviously it's not the greatest photo in the world, but you could see it from such a light polluted area. I haven't tried in LA actually. So that's sort of where I was planning on ending my presentation, but then I was looking back at my photos that I took, just sort of putting together these slides. And this is, I put it at Jupiter just to see what would happen. And not much is the answer. It was just sort of this big white blob, which made sense. And it actually took a few tries. My first one was pretty blurry, and I didn't set it correctly, and it wasn't for the full 30 seconds. And so it turned out like this. But when I looked a little bit closer at where Jupiter was, it actually looked like this. And I have no explanation for this. Who knows? This might have just been a trick of the light. But one thing I was interested in is seeing, is there a chance that this, obviously it's the same photons, hitting us. Is there a chance that this was somehow captured? And I think one way to tell would be if the red spot, which I thought was this little thing, was pointing at us. But, whether or not it is, I don't really, take any pride in this image. But I was curious about how to tell what Jupiter looks like currently, sort of what website I would go to see where Jupiter is in its rotation, because I actually wasn't able to find that online, and I figured maybe somebody in this group knows. So feel free to put it in the chat if you know kind of what website that would be. So given all this, I had a few different ideas about what we can, what we can do to save some taxpayer money here. Figured we can just put an iPhone at Lagrange 2 and call it a day. I think Arthur C. Clarke said we are fish staring up, in a muddy pond. And so just imagine what an iPhone could do at Lagrange 2. Something like this, I would imagine. It'd be a great ad. So thank you, everybody. Happy to answer any questions. Hope you enjoyed.
Yeah, I've got two. So one is, how do you get a 30-second? Do you need I got an iPhone 12 and I can get up to 10 seconds. How do you make it 30 seconds?
Yeah, so I thought it only went up to 10 seconds too. But I think maybe when it was just really dark and when the phone was absolutely still, it automatically went up to 30. I couldn't,
really?
I just slid it over to 10 and then I would set my phone down and I would sort of see, wait, it says 30 now. So I actually didn't Google it, but somehow it did 30. Yeah. And it was amazing.
Okay. Very
Did
cool.
you use a different app, or it was a regular iPhone app?
Nope. Regular camera, just with with this night mode, setting here.
And then the
This guy.
second question I got is that you seem to have a little homage to Hubble with the Nova variable thing. Was that actually the variable? Is that the second?
No, this was just my attempt at a joke.
That was just
one of
a little
many.
humor there. I was gonna say, because I'm thinking Hubble's picture was a lot clearer than that.
I think what we can say with certainty is the star is actually there, though. Whether or not it's in my picture is another question.
I got you. Thank you.
You can do pretty well with time lapses of the Milky Way. I have an iPhone 13 and I put it on a tripod at Lockwood, and I've shot time lapses, 30-second time lapses, and it's really great for that.
Yeah, I bet. I mean, I wasn't really prepared at all. It's kind of like
And
I'm
again,
sure that I could do much better.
I want to ask, so your 30 seconds, that just happens? Because all I can adjust my iPhone is for 10 seconds. So how do you get 30 seconds?
I think there's a slider on there that you can move on the bottom.
You can slide it all the way to 10, and then somehow it just magically started doing 30. So
okay,
maybe it was like some update or something. But yeah, I wish I had a better.
I'll have to believe in magic. Cool.
Yeah, I wish I had a more replicable explanation, but it worked every time when I was there.
But Spencer, you mentioned a different word when you said in the beginning. It was in what mode? Time lapse.
Yeah, time lapse.
So if you go to the time lapse part of your iPhone, in the time lapse, I think you can set how often or how long it takes to picture there.
Well, so is
Might be
time lapse the
different.
same as night mode? Because night
No.
mode
No,
No,
gives
it's
me
not, no.
by default 3 seconds, and I can extend it to with a slider to 10 seconds. But I've never seen 30 seconds. But again, under dark skies, maybe it automatically goes longer. I don't know.
So the trick for the time lapse is you have to go into night vision or night camera mode and set it up there, and then you slide it over to time lapse and hit start. And so then it keeps the same settings for the time lapse exposures.
Okay, yeah.
Jeff,
Oh, that's cool.
All right, I'll experiment.
give it a try, David.
Okay.
Jeff, have you tried iPhone 14? I heard iPhone 14 is much better than 12, I think.
Oh, no, I haven't, but that's enough reason for me to get one. No, this is a 13. And
Also, did you do some processing on this image, or is this just the raw as is?
absolutely zero processing. This is like exactly what I looked at on the phone.
No, but you should do some processing. I'm sure you can bring out much more details than what you have on this phone.
Yeah, no, I was taking notes during your presentation about the software and everything. I'm sure that this is like, I'm sure it could look much clearer.
Just the editing tools in the phone itself. Once you do it, I'm sure you can take out a lot more details in this.
Yeah.
And by the way, I'm sure a lot of folks have done this, but if you're doing outreach and you're looking at the moon or something bright, you don't actually need night mode for this. Night mode will overexpose. But, you know, iPhone behind the eyepiece projection, iPhones do a fantastic job on the moon, and Jupiter pretty good, and Saturn pretty well. And it's all a question of alignment. But if you want to make one of your visitors very happy, just say, hey, do you want to take a picture of the moon? And here, let me hold the iPhone for you. I'll let you take the picture. Let them push the buttons. And the only issue that you sometimes have with iPhones is you have to basically reduce the exposure, because the default exposure, it wants to overexpose. So you tap on the moon, you slide the slider down to reduce that exposure, and you can make the public very, very happy in outreach by letting them on their own phone take pictures of the moon.
Yeah, and I'll even add one story to that. So I used to work in a lab in college, and I would do the same thing, but for a microscope. And I would take insanely clear photos of things like cells underneath the microscope, and actually, scientifically valid and acceptable in peer review. So that was one thing that was very eye-opening for me. I think it's the same principle with telescopes.
Mm-hmm.
And 30 seconds is coming from the sky, because I just turned mine on and it said 3 seconds. I blocked it off a little bit. It went to 10. I laid it down flat on the table where there's no light. Now it says 30 seconds.
Yeah, I was quite bewildered. So I'm glad that that is the real explanation.
Things you learn.
I'm not sure. I'd have to check, but I think it's actually stacking 10 seconds stacking the exposures.
It is a stacking, and it actually does the alignment. It's really stunning what's going on in the iPhone. It does a little bit of alignment. It does a little bit of stacking. I didn't know about the 30 seconds thing, so that's very cool as well. But yeah, it's you can get some amazing pictures.
Interesting to find out how long those subs actually are, if it's stacking over 30 seconds.
Mm-hmm.
I know somebody at Apple that might know. I'll try to find out.
We got connections.
All right. By the way, the link for the drawing is posted in the chat. Okay.
All right, thanks everybody.
All right, thank you, Jeff.
Thanks, Jeff. That was awesome and funny. I laughed in the right places. I got your jokes. It was pretty good.
Yeah, this is the workshop, so glad.
Okay, Kenji.
Hello.
Hello.
Can you guys, okay, everybody can hear me?
Mm-hmm.
So my name is Kenji. I've been a member of LAS for about 3 years now. I actually joined around 20 something years ago originally, and was a member for a year and didn't do anything with it and let that lapse. And then came back when my older son started getting into astronomy with me. So I'm a scouter. My older son is a fourth year Cub Scout, and he's a Webelow Scout. And I'm one of the leaders within the pack. I'm actually the committee chair. And I'm also a science teacher with the BSA through the NOVA STEM and Supernova program, which is like an auxiliary science education program through the BSA. So I have a group for the last 3 years that have been, we've been doing a lot of science, particularly astronomy over the summers. And this year they're working on something called a supernova, which is a bigger level than what they've been working on before. And they're all 4th and 5th graders. And then we have a couple of 2nd and 3rd graders as well. Actually, Greg came out and brought a group a couple of years ago during the pandemic out to our Cub Pack, an LAS group, to help kind of introduce the pack as a whole to astronomy. So thank you again, hat tip to Greg for your help with that. So this year with the supernova group, we had a heavy emphasis in astronomy among other sciences. And we started with as far as the astronomy stuff goes, we started with a hike in the summertime to the Griffith Observatory. Can you guys see that here?
Yeah, you're good.
Okay. So this includes a couple kids from a couple different packs, and like I said, between 2nd grade and 5th grade, although the core supernova kids are 4th and 5th graders. And we hiked up to the observatory, and we got a chance to talk about the historic Zeiss 12-inch scope there and got to look through that. I think they had that pointed at the moon that day. We got to, they of course have, as you guys all know, they have a ton of awesome exhibits on planets, and we talked about moon phases, eclipses, rotation versus orbit. This is the Zeiss here in the observatory. We looked at planets, and we got a chance to kind of talk about our place in the galaxy there. They have some very good displays of that downstairs. They did have us wearing masks there. It's a city facility, so they're pretty strict on the masks, and the adults had to have their COVID vaccinations, much to the chagrin of some. And I did not take these particular photos. This was another parent that was with us. I'm generally too busy to take the photos on these trips, but that was an awesome day trip that we had as a group. We got to talk a lot about what the scouts were working on with like a picnic lunch on the lawn out front there before we went inside as well. Then in November last month, we had a camp we did. Here we go. Hang on. Are you guys, this should be okay, this looks like the right one. So we had a rocketry camp we did with Skywatching to satisfy a couple of the requirements. So we had built model rockets between the late summer and early fall. And the scouts learned about Newton's 3 laws of motion, as well as the chemistry and the black powder engines. We also got a donation to use composite engines as well. I had them all, we talked about stability and kind of how the rockets are working. And we get basically a introduction to rocket science. So this is actually my son here testing a rocket for stability. We had 10 rockets out there with a total of 10 rockets, around 100 engines. That's a 2-stage rocket that I built to demonstrate. And we had 4 launch pads somewhere here. I got an image of here we have 4 launch pads you can probably see here. That got to be a bit much because at times people are watching different rockets, and it got a little tricky with some of the higher ones. So we also, some of the older scouts, we did a little bit of math. Some of it was above their head, but on calculating altitudes and estimating speeds. I payloaded an onboard camera on that 2-stage rocket and got some pretty cool video from that rocket a couple times as well. That rocket did actually get lost, and then I found it the next day when we were driving out there. That was at El Mirage, the dry lake bed northwest of Victorville. And that evening, we then change here. That evening, we had about an hour of wind before we then got to settle down for a really pleasant night of sky watching. It's about a Bortle 4 or 5, probably closer to a 5 sky out there. Victorville and LA still kind of close. But we did get to see a great deal of things. We started out with just a laser looking at the constellations. A lot of the scouts were able to pick out, they tried really hard to find the Big Dipper, but it was mostly below the horizon. So we only saw the handle, but they were able to identify, some of them were able to identify Cassiopeia, and the Little Dipper and Polaris really led us to the Little Dipper. Andromeda and M31, which we later checked out in the telescope that I brought. Going from the west also, we saw this, we were able to still see the Milky Way, so maybe closer to Bortle 4. Cygnus with Deneb, Aquila with Altair, Lyra with Vega. I should point it out Pegasus, but really just the Great Square. Later in the evening, Taurus rose with Aldebaran and M45, Pleiades, the Hyades cluster, also Orion, Betelgeuse, Rigel, of course, the Nebula, and Gemini. So that having to identify the stars, most of them weren't really able to get past Polaris repeatedly, but they were eventually able to kind of find Deneb, Altair, and Vega, the triangle there out west after a few times. We also talked about how telescopes work. So we spent a lot of time earlier in the day talking about Newton's 3 laws of motion with the rockets, and Newton's, what a Newton actually is. And Newton's is also really famous for his telescope design, which was really the first to use mirrors to correct for chromatic aberration. So the telescope I brought is a simple 114 millimeter f8 Newtonian reflector on an alt-az mount. It's the OTA, the tube assembly, is about 25 years old, but I rebuilt it around 10 years ago or so. It has the original primary mirror, but a new secondary mirror, a much better, much larger focuser, new finder, Vixen mount, and of course, better eyepieces. So we talked about how that works and what Newton's design was. And they had a good time. Like they had a really good time seeing a lot of some of the deep sky objects. And then of course, you always get a lot of wow factor with Saturn's rings. We had enough seeing to be able to see the Cassini division at about 160 power. Jupiter, the spot was up during, it had revolved around, so we were able to find the red spot as well. And of course, the moons, the Galilean moons. Mars rose while we were out there as well. Although it is close to opposition right now, but it's not as what it was a couple years ago. So we didn't really spend a lot of time with that. And we also looked at a couple of the open clusters with some 10 by 50 binoculars. This is an illustration my son did a couple of years ago for the presentation we did with Greg, actually, of that telescope. Just to wrap it up, after bed, popped an image with Orion, and I think this might have been on like an 80mm lens or so with a mechanical tracker. So nothing too fancy, not like Nasir's quality, but you can see M42 right there, and Rigel and Betelgeuse are pretty obvious as well. So it was a good time. The scouts had a really good time, with the exception that everybody pretty much from that hour of wind got sick the next week. So everybody missed school for a bit, but it was a lot of fun, and the kids, really get excited about it. And Greg, I think at some point we might need to set something up again with the pack. They would be thrilled.
Yeah, congratulations, Kenji. That's really great follow-up for the scouting. And I know some people think that kids these days aren't getting enough science. That's not always true. They are getting great science. The club is very supportive of our efforts here with the scouting program. I'm currently registering for the Nova/Supernova STEM Award, and I'm going to do a group next summer. We're going to do 3 merit badges, and then we're going to do the Nova Award. The Supernova, of course, requires the rockets and all this other stuff. For those of you who don't know, Boy Scouts get badges at different levels. These are not easy awards to earn, even at the Cub Scout level. There are quite a few requirements, and not many people in the entire council earn these awards at all. So we're going to do that program next summer. I'm going to do 3 merit badge classes at Garvey, and then we're going to do a group to go for the Nova Award as it relates to astronomy. So that's great news. And yeah, we should talk. We have a pack coming on January 18th, and I think the Webelos Den is going to go for the Astronomy Nova. So I'm communicating that right now and working with council to make sure we can get that signed off. They got to go watch some videos and do a few things beforehand, but I think other than that, we can do all the stuff in one night. So great. Thanks for letting me plug what's going on next year with the scouting program. You're the best advertisement we could ask for. So you're one of the reasons that people support the program so well.
Awesome. Thanks, Greg. Yeah, I will be in touch. Let me know come summertime if you need a hand.
Oh, yeah. Well, great. And we have a new Eagle Scout that just registered, a young man. So we're going to get him right in there to help us too. Yeah. So that's great. That's great.
Perfect timing.
Yeah.
It's really great to see you guys here at our meeting, giving presentations, and the reciprocal. We really like to have the Boy Scouts at Garvey and do Boy Scout Mount Wilson as well. So thank you guys very much. You do work hard, and it's nice to see those boys learning something, and they really do learn it. Thanks.
Thanks, Daryl. Thanks, everyone. Appreciate it. Good presentation, Kenji. Thank you.
Thank you.
Thank you. Thanks, everyone.
All right. Next is Richard Sutherland, the Pi Finder positioning and push to for Dobbs without encoders. Richard, you want to take this?
Yeah, thank you. And thanks for everyone who organizes this meeting. It's the first one I've actually attended in person, so it's pretty awesome. I think it's a good one to kick off with. Start sharing my screen here. Yeah, so thanks for letting me share this a little bit. It's going to be kind of a combination of a personal journey here of what I wanted to kind of accomplish and some technical stuff, hopefully with some time for questions. So I'm Richard Sutherland. Been a member for about 4 years, but haven't really made enough use of my membership. So looking forward to getting back to Lockwood. Went there the first time a couple months ago, really enjoyed it. Met some cool folks. Sorry, I don't remember all the interesting people I met there. But this is a preview of kind of where I've ended up through this journey. This is what I'm calling the Pi Finder. And I guess I wanted to give a little bit of background here. This is my scope as of 2016. It's kind of how I built it. No electronics at all. Pretty dead simple. Used it that way for about a year. And then I was fortunate enough to win one of these fancy Nexus DSCs at a door prize at an astronomy club that I was a member of at the time. And seemed like a cool gadget. Wanted to try to get it kind of hooked up here. But the design of the Dob really doesn't lend itself to encoders. So this is sort of what I came up with. And it works. It's not coupled very tightly to the scope. So there's some slop, but I've used it this way for about 5 years. And in that time, I got really used to when it's working well, it's aligned well, and the astronomy gods are shining down on me. I can find stuff and I can look at more objects than I could just walking to the star chart and then matching that up with the sky. So really enjoyed it. But over those 5 years, I came to realize that there's a few things that I wanted to change, and that's what kind of kicked this off. So I really wanted to have something with quicker setup. The Nexus DSC is a great unit, but you need to do multi-star alignment. It takes a little bit of time to do that. In my case, because of the way it's coupled to the scope, it often gets off track, so you may need to realign it a few times during the night because those friction wheels slip a little bit all the time. So I wanted smoother operation and quicker setup. So I had more useful observing time. I don't get out under the stars an enormous amount, so I want to try to make use of that time. And one of the things I really wanted is better certainty about where the scope was pointing, especially when I was hunting, fainter objects. I'd try my best to look through the scope and use all the techniques. But if I don't see it, is it because I'm not quite in the right spot, or because it's just below the limit of my visibility there? Sometimes I could piece that together with a good star chart, but it took a long time to really verify exactly where I was to find out whether I was just missing it or whether I was just off base. So a couple of the things that I thought might be nice, something that's night vision friendly. A lot of people use tablets and iPhones and stuff at the scope. Those are great, but I always found them a little too bright. It would be nice if it was customizable. If it had integrated logging, that'd be great. Again, trying to spend more time at the eyepiece, less time kind of going over to the table, making notes and such. And I like projects, so I wanted something that was fun and interesting, ideally. So, I don't get out under the stars much, but I like astronomy a lot. So I spent a lot of time thinking about it, and I spent some time kind of doing some research, looking at what was out there, what some other people had done. And I decided that these were sort of the features I wanted. I thought plate solving would be kind of a cool way to get over the fact that I can't, affix encoders really firmly to my scope. Want to be able to search a catalog. I'd love to have push-to guidance. That's one of the things I love about the Nexus DSC. For those that don't know, if you don't have motors, it'll just tell you which way to push the scope, and eventually you get where you want to go. That requires some GPS, and I thought, well, it'd be cool if it had observation logging again, just to spend more time right at the scope. I knew some people had done these sorts of plate solving with Raspberry Pis, so I decided that was probably a good place to go. Had some experience with their camera and CCTV camera lenses, so decided to pick one that gave roughly a 10-degree field of view, which seemed good. But to make it self-contained, I decided I want to do a custom printed circuit board with a keypad, some arrow keys, and a display. Ideally OLED, because it can be very, very dim, all the way down to basically black, with no light leakage. And I thought that it would be a good idea to try to integrate an accelerometer or an inertial measurement unit, just so that in between the times when it was actually still and taking a photo of the sky and solving that, I had some guidance, how much further I should push it before I got to the target. So that required a GPS dongle, and I already had, by this time, dew heaters on my scope, so decided to plug it into that power supply that was already there. I know Python, so I decided to write it in Python. I thought it would probably need to be multi-threaded just to get through the photo taking and the solving and overlap some of that time. Tetra 3 from the European Space Agency seemed like a good bet. They have a really nice what they call lost in space solver. It's a plate solver, but not quite at the level of accuracy that other plate solvers do, but it'll tell you where you are in the sky. And then there's a great Python set of tools for plotting and other astronomic calculations. So I decided to start with the hardware because I like writing software on the hardware. I find it much more satisfying. So these are some early prototypes. They kind of worked. There were some refinements, but I eventually got there. You can see the camera here. The Raspberry Pi is mounted on the other side of this. I hope you can see my pointer because I'm pointing. But anyway, great. Thanks. And then the keypad sort of fits on the top here with a nice little cover. And it came together in time. There's a sort of cell here that holds the camera for scope alignment. Worked out pretty well. Pretty well-worn pattern from mirror cells. And then I started developing the software. Not a lot of visuals here, so I grabbed some of my early sort of designs to figure out what you could actually show on a 128 by 128 pixel screen. Wrote a bunch of Python code over the last few months. And this is where I'm at. So this is the hardware as it currently stands. It's got a GoPro mount on it for this testing purposes. I've done a fair amount of testing on a tripod with it. Here's some screen grabs from the UI. It gives you a camera preview. You can search a catalog. If you select something from the catalog, you can get some push-to guidance, and it'll give you a little star chart of where you're pointing with some cool features, and it'll indicate kind of where your target is. Here's it on the scope. You can put a Vixen rail on it, which I'm using here to mount it. Unfortunately, I haven't had a chance to actually get it out under the sky on the scope. I'm very, very excited for that to come probably in January once the snow melts. But I've used it on a tripod and it seems to point in about the right place as far as I can tell from the sky. It's open source, so I'm looking for anyone who's interested in collaborating on making this thing better software or hardware wise. And let's see, so what am I up to next? More testing. I'm halfway done with kind of observation logging while you're looking at targets. I want to be able to load observation lists. I use Astro Planner, but there's a lot of good planning software out there. And I want to be able to plot deep sky objects on the chart. So if you're pointing at a certain place in the sky, you might notice something interesting there. I want to filter the catalog by altitude. That takes too long now. More catalogs. It has the IC catalog, the NGC, and Messier now. User manual, some build guides in case someone wants to put one together. Raspberry Pi 4s are hard to find, so I want to test it with a 3, see if that goes, and probably upgrade to Python 3.11 just to try to get a little bit more speed out of it. So I think we're about 10 minutes in, if I'm not mistaken. I just want to pause to see if there's any questions, and then I have some kind of walkthrough of how it's generally used, so I can just plow forward through that. But want to see if anyone had any questions before I kind of just raced forward here.
How long has this taken so far?
That's a great question. So I started it in, oh, sorry, I see someone in the chat there. I didn't have been keeping attention here. Probably started in earnest with the build in September. But as I said, I spent a lot of nights just dreaming about astronomy when I couldn't get out from, the light dome of Los Angeles or the weather was bad. So there's probably a few more months before that where I was kind of collecting up all the bits and pieces and trying to sketch out ideas about how I wanted to build it.
How did you find the sensitivity on that camera?
It's pretty good. I settled on about a 1.5 seconds exposure, at least where I've been testing it in Santa Monica. That gets me down to magnitude 7 stars. So it's kind of a balance between, of course, saturating the sensor with the sky glow here, which I don't think will be a problem, of course, under dark sky, and getting quick turnaround time on the solves, and then getting enough stars, basically. So I haven't pushed it much further than magnitude 7 because that seemed to be plenty of stars all over the sky for the solver to kind of pick out the location.
That's the same camera we use on the All Sky Cam at Lockwood. And
I thought so, yeah. Do you have an exposure time that you generally use on?
yeah, I'm trying
that
to
one?
I'm trying to remember. I think it's the 10-second exposures.
Well, one of the features I thought might be cool is as part of the logging process, I figured it could switch the camera over to a longer exposure and take one to kind of stash away full resolution, because it's usually doing 512 by 512 little images to solve. So I thought that might be a cool feature, and I think I might do that because I've seen some pretty good images come out of that all sky camera. So I'm excited to test what can be done.
Okay, Spencer, I'm here.
Oh, okay. Thank you, Dave. All right.
So let's see. Probably have a couple more minutes. I'll go through this real quick. You start it up, takes about 45 seconds. 15 seconds after that, you get a solve. Looks like this. This is a preview of the camera with some sky subtraction and a little bit of histogram stretching. Solves in about 0.2 seconds, and it overlaps that time with the exposure time. So you get a new solve every second and a half, basically. Once it's solved, you can get a star chart here, adjustable reticle. It'll plot stars down to magnitude 8, constellation lines. It uses the inertial motion unit, so you can actually move the scope, and it will update the display about 10 frames a second. And then once you stop, it'll solve again and take out any error that might have been accumulated. It's got multiple zoom levels from 5 degrees all the way to 60 degrees. You can kind of zoom out and get a kind of view of where you're looking. Clicking the mode button will get you the catalog. You can switch catalogs. Start typing, and it just immediately tells you what you've got. So 7 will bring up M7, 7.3 will bring up then M73. You can go up and down, kind of scroll through the catalog there. You can filter by object type, magnitude, and ideally altitude limit, but it just takes a long time to solve the altitude for all the objects in the catalog. Once you find an object you want, press the enter key and you'll get some pointing guidance. Shows degrees and direction to target, updates real time. You can also use the chart, and it'll present you with a little arrow, kind of guide you to your target there. I found that pretty useful on the tripod. I don't know ultimately how close it's going to get to, let's see. Yep. To perfect. I'll have to take it out with the scope, and that's my next step. Hopefully get some logging in here. I thought it would be nice to rate the visibility and the appeal of it. I thought you could hook up a microphone and maybe record an audio note for logging. Image would be kind of cool too. I'll have to stash that away. And then you can get status of the last solve, its current position, and so forth. The title bar always shows you the constellation I'm pointed at and some other business. So yeah, that's where it's at. As I said, I'm looking for any collaborators that are interested in contributing to this kind of project. And yeah, let me know if you have any questions, I guess.
So this is all written in Python?
Yes.
Okay.
Yep.
And since there's since there's no encoders, this will work with any telescope, really, right?
Yeah, all the displays in the math are designed around taking right ascension and declination, and kind of translating that to altitude in azimuth for DOBs. But there's no reason it couldn't work with an equatorial mounted scope.
Right, that's kind of cool because you can just kind of like on a whim, just and then there you go. You don't have to.
Yeah, and it just goes right on the finder shoe, so it's easy to move from one scope to the next. You could build one with self-contained power, which would make it a little bit heavier, but it would, make it that much easier to move from scope to scope.
Yeah, cool.
Got a question.
I think it's amazing.
Why did you go with the Pi rather than an Arduino? You got any ideas about that, or any preferences, or is it just what you did?
It's I've used Arduinos for a lot of projects. This one just required the extra oomph of having multiple cores, and the Pi 4 has 4 different CPUs, so it can kind of be doing a lot of things at once to keep the UI responsive. And plate solving is not super trivial, although the ESA has done a pretty amazing job making it computationally less expensive. But you still need a fair amount of oomph to kind of do all of this stuff all at once.
Okay. Yeah,
I'm just gonna say this is incredibly cool.
Yeah.
I'm very interested to see where you get with this.
Yeah, well, look for it at Lockwood after the snow melts.
Yeah, well, you've got to tell us when you're going to do a demo when the weather's better. I think you'll have some fans that want to come up and see it and learn more.
Great. Well, thanks everyone. Reach out with my email or the address there if you have any further questions.
That was really great. Thanks, Richard.
Great, thank you.
Very cool.
Thank you.
So cool.
All right. So next is Tim.
Thank you very much. You guys ready? I'm Tim Russ. I've been with the Astronomical Society for quite a while, probably around 20 years maybe, and just renewed my membership, so I'm back. This may have been demonstrated before, the telescope that I have sitting over my shoulder here, the Unistellar. My primary goal has been over the years optical astronomy. So the scopes that I have are all Dobsonian, Schmitz, and Maksudovs, and I've been using them mostly for optical observing. So it's planets, stars, and dark skies for the nebulas and clusters and things like that, and galaxies. So it's all been optical, and I haven't invested before this in any computerized telescopes until this thing came out a couple of years ago, and perhaps you have seen it around. Some of you have probably seen it and looked at the images. Several of our members also have one, and it may have been demonstrated before this. And if so, I won't take too long on it. For those of you who haven't seen it or know anything about it, I'll run by this pretty quickly. So this telescope, what it does, it is an actual telescope. It has an eyepiece. It has a 3.5-4-inch mirror in it. It has a digital magnification system, so your objects are going to be a little larger in this than they normally would be in what is relatively a small diameter telescope. It only has 2 pieces. It's the telescope and the tripod, and that's it. It works off of GPS on your phone. It has an app that it comes with. And so the telescope will know where it is based on your GPS. Therefore, there is no 2-star alignment or any of that. The alignment process takes about 10 seconds. Once you have the phone's location set up and you have the Wi-Fi turned on. Wi-Fi is built into the telescope, so it communicates with your cell phone. So you are talking to the thing the whole time. So it knows exactly what's going on. It will align itself with a background of stars, and then you're done, 10 seconds. It has a catalog of thousands of objects built in. You can also manually input the objects, of course, if you have the coordinates. It will lock onto those, slew and lock onto those objects and track them. The very good thing about this telescope, it is a combination of a telescope and it is an imaging system. It has a Sony imager inside, but the trick is that it has an accelerated layering process so that you can get the images of these deep sky objects within 3 to 4 minutes. And that's within the city of Los Angeles, dead in the middle of the city of Los Angeles. It has a filter built into it, so it can eliminate and contrast the back sky. And it's very effective. I've used it up at Griffith a few times. People are absolutely blown away by what they can see through the eyepiece. The eyepiece itself is a digital imaging eyepiece. So you're not going to see the twinkle of stars, but you will see the stars. It does not work that well on planets and the moon because they are very, very bright. This telescope is designed for looking at deep sky objects. So, if you've got an optical telescope, it's still great for using it on the planets and the moon. And so this one is definitely much more for the faint, opaque, and deep sky objects, which does a great job. It also, they have a citizen science program that's built into the app. So you can actually participate in missions, if you will, that they list within the app that you can, sign up for and actually go ahead and proceed and do. I did one for NASA a while back for the Lucy mission. They were doing an occultation of an asteroid. I was able to do that with this telescope. It took 4 minutes. The setup was 2 minutes or 3 minutes, 4 minutes to do the occultation. You send the data, download the data. When you get back home, you just download the data to them, and they'll send you back the movie that the data, once they've crunched the numbers that they've come up with, and you can see the actual occultation. It'll do a light curve, and it'll also do a movie. This telescope will also track exoplanets around other stars. It will track the light curve for that. Now it takes a few hours to do, so it's longer. It will also track asteroids that are mostly near Earth asteroids that are visible right within the city. You don't have to go to dark skies. I've done that with this telescope as well. That took about 30, 40 minute sessions, just leaving it on there, stopping it, starting it, stopping it, starting it, 3 40-minute sessions. Crunch the numbers, they send them back to you, and you have the movie. So it's a very useful telescope, runs about anywhere from $3,500 to $4,500. They may have specials going on during Christmas time, I don't know. The eyepiece version is $4,500. The version without the eyepiece is $3,500, roughly around there. On your cell phone, the images will be captured. You can download them, send them to yourself, download them, and process them all you'd like. I'll show you a few shots I've got from the telescope. They haven't really been processed that much. I mean, I don't have any special processing software. Might have boosted the color or the contrast or the brightness, and that's about it. Takes about 2 or 3 minutes. So I'm going to try to share my screen here with some of these images. Let me know if you see them. Let's see here. Do you see them?
Yes.
Yes.
Very good. That's the Dumbbell Nebula, and that was shot within the city of Los Angeles.
In terms of double stars, I mean, so you're talking about the planets being too bright.
Yes.
What kind of magnitude of stars you're trying to do? Double stars, or things that are intermittently bright, not deep sky, but like double stars.
Stars are not a problem. It's just the objects like the moon and planets are really, really too bright. You can get double stars.
Saturated. Okay.
Yeah, you can get double stars on it. I have not imaged thus far, really sought to image Albireo or anything like that with this one yet. I think I will the next time I go out, but if it's up. But I've done mostly the deep sky stuff. But it'll do stars without too much problem.
Okay.
You'll see them pretty decent. I still think, quite honestly, that your double stars are going to look better in an optical telescope. If you're looking at something that sharp and pinpoint, I think they'll look a little bit better in an optical scope. I like this telescope primarily for the faint objects. Looking at this is the Eagle Nebula. And again, this is, it's a 5-minute exposure. That's it, 5 minutes. So you can you can process a little bit more, get some more contrast and color with a really good imaging program. You can do that as well. This is just the built-in stuff on my laptop, nothing special.
Yeah, Tim, when you're using your eyepiece on this, do you see the red color, or?
Yes, you do. You can see the color through the eyepiece.
Oh, really?
Absolutely, yes.
Oh, cool.
This is Comet Neowise that I did. It's Comet Neowise. That was imaged in the valley. I was just in the valley here in Los Angeles. And it was a very short exposure. It was pretty bright. That was pretty nice. A great job on it. This is the asteroid clip that I shot. This is Nereus, asteroid Nereus, near Earth object. And you can see this is what happens after the 3 different exposure times. They crunch the numbers and they send them back to you.
What magnitude was that asteroid? Do you recall?
That was it was around 12 to 15, somewhere in there.
Oh,
and
okay.
it locked onto it in the city and got it in the thing. I was surprised, actually. I didn't think I'd be able to do that.
Thank you.
Yeah, this is the occultation of Patroclus, the asteroid Patroclus. And this is what they used for the NASA project. You can see the light curve on the bottom. Watch the asteroid disappear. There it disappears. And there it comes back up again. And so, again, that's something that they asked me to do at the time. And then NASA was able to take this information and put together approximately what the shape of the asteroid was before the probe reaches those asteroids in Jupiter's orbit. And so this is the Whirlpool Galaxy. Once again, I think I put this object up when I was at Griffith a couple of sessions ago, and people were just amazed at what they could see, you know, with the telescope in the daylight, in the night skies of Los Angeles, and it's really good. So this telescope for me, you know, because I prefer basically the learning curve is more like a rock with a light switch. That's my style of learning curves, and that's what this telescope is: rock, light switch. That's it. It's very simple to use. If you have the telescope, there's plenty of instruction online. There's just little things, lessons to get you up and running. And then you have a few specialty things you can go over, but it's very simple. You need an iPhone or an Android that's relatively new. If it's really old, they may not support that anymore. So you need something that's fairly new for the app to work on it. A larger screen is better than a smaller screen, et cetera, et cetera. But that's it. So if you have any questions, let me know.
One question on the occultation that you showed. What was the occulting object?
What was the opposing object?
The occulting object. So the asteroid disappeared.
Yeah.
What did it disappear behind? I didn't.
It was a star. It actually crossed in front of a star.
Oh, okay.
Yeah.
I saw it dim down. I couldn't really see the star. Okay, thank you.
Yeah, it's actually, what you saw was the actual was the star.
Occultation.
Yeah,
occultation of a star, not an asteroid.
Yeah, it's not the asteroid.
Yeah.
The occultation is the asteroid crossing in front of the
So you
star.
couldn't actually image the asteroid. It was the star that dimmed down.
No, you're just on the star. Yeah,
Gotcha. Yeah, thank you.
Now the other one was the actual asteroid.
Yeah.
That was Nerus, and that was a near Earth object. There's a couple others I was trying to image. I don't know, 2 or 3 weeks ago, and the bloody clouds were there for an entire week. So it was not, by that time it was gone. So anyway, that's, if anybody has any questions, that's essentially what I have been using for like the last year and a half. It's just an absolutely remarkable telescope. This is all new. This is all now, you know, the technology of the 2000s, and it's only going to get, I'm assuming, bigger and better, and somebody else is going to come on board and they're going to come out with their version of it, because this, I think, is where it's happening. How
many versions do they offer? Do you know?
Right now they have one version of this without the eyepiece, which is the Equinox, and it's about $3,000 to $3,500, and then they have this version, and they are working on a new something right now, which they will not tell me, not even give me a hint as to what it is, and I've asked them a dozen times. They're working on something brand new, probably for 2023, sometime in there. But they have this version with the eyepiece and this version without the eyepiece.
Thank you.
And again, it's
what's the micro used on that?
What's that?
What's the microprocessor used on that on your machine?
I am not absolutely certain what the technical specs are on the processor off the top of my head. You probably have to go and research it a little bit online.
Phil Taylor knows.
Yeah,
Phil Taylor knows.
Dave might know as well. I don't know. Yeah, but it's not as powerful as it potentially could be, and I think that they're probably going to upgrade it even more so. I think this has, you know, it has a ceiling to get to. It can go even higher and better as time goes by. The longer you leave the exposure, and particularly in dark skies, the better the object's going to look, the better the contrast of the background's going to be, et cetera, et cetera. But my primary, you know, use for it is within the city. I just use it in the city, and what it can do in the city is, well, I've just showed you those images. A lot of them are, you know, with city lights all over the place. So it's.
Is there any potential for hacking into it, or is that just an absolute no? Is it a black box or what?
Yeah, you know, it will when you're using this telescope and you're up there with maybe one other one like it or something else that uses Wi-Fi. You just have to turn off the Wi-Fi signals from anything else. Tell your phone not to bother with any other device, and it locks out those things, because sometimes it will overlap, and you might pick up somebody else's unistellar telescope as far as the Wi-Fi connection. I don't know if there's anything as far as the hacking goes, if there's any security issues with that. I don't know why anybody would want to, but I couldn't tell you. I don't know about the technical aspect of that potentially happening.
Tim, that was really great. There's a bunch of kudos for you in the chat. If you want to look back through there, people are saying how cool it was to see this, and see that that aspect of it. And I talked to you out at Garvey just a few weeks ago when we were there.
Yeah.
So, very, very good. Thank you so much.
Thank you. Thank you.
All right.
Thanks.
Can I ask a quick question, Tim? Did you find with that scope any difficulty with Neowise because of how bright it is?
No,
or it was.
Neowise was not very. It was barely. I don't think it was even visible with the naked eye. That comet was not naked eye visible in the city, and I was in the valley, so I was not in dark skies. So it was not visible to the naked eye, and I was able to. The exposure time was really short. As soon as I got it in there, it came out, and I just stopped it from that point on. I didn't leave it going. So I didn't need to make a long exposure. I did try to shoot one other comet, which was much more faint, and I did not get as bright as I really wanted to. But I did pick it up, and it was also not visible. So if it's a visible comet to the naked eye, it's not going to take but a second once it locks on. The telescope itself, when you first acquire the object, it has works like a regular telescope. It does have digital magnification. It's got a small mirror. You might see the object in the telescope, but it won't be that bright and detailed. The feature on the telescope is it has enhanced vision. Once you punch the enhanced vision, that's when the processor takes over and starts layering the image. And it just does it over a period of seconds and then minutes and then it's done. So that object will come in. So if you have that comet in sight, and you can barely see it with naked eye without the imaging, once you push the imaging, as soon as it gets that first 2 or 3 layers, you'll probably have enough, to be able to cut it off or make a still image of the comet at that point in time. And
Tim,
yeah.
I'm sorry. Have you used this under dark skies at all?
Absolutely, yes, I have. I used it at Lockwood Valley twice. I think Lockwood twice, which is magnificent because I can image even more faint objects with it. Yeah.
Okay, so it's not just limited to light polluted skies.
Oh no, absolutely not. No,
dark skies.
No. The dark skies are always going to be better. You have much more contrast, and you have much more opportunity to image more faint and difficult to acquire. In the city, some of the really where the objects are just really faint. The magnitude's up around 9, 10, 11, 12. Those are not going to come in that well in the city without leaving it out there for quite a while to try to grab them in. They'll bring it in, but it's much, much better for those kinds of objects to go to the dark skies. So the objects that I'm looking for, I'll look at the magnitude first to see what magnitude they are. And if they're under, if they're around 6, 7, 8 at the top, then I'll try to image them within the city and they should come out okay.
What is the field of view of the sensor?
The sensor field of view is tremendous. I don't have the actual numbers. But if you're looking at it, you just walk up to the telescope and look down.
Yeah.
People with glasses, not a problem. You can stand back about that far from the eyepiece and see the entire image. It's very, very wide field.
Okay, but I mean in terms of angle, so Orion Nebula.
Oh yeah.
Margin.
No, I can get the Andromeda in just about all of the Andromeda.
Okay, the Andromeda. Oh, great.
Yeah,
perfect.
yeah.
Okay, that helps. Thanks.
Yeah.
So Tim, when it starts taking images like I do from my backyard with my telescope and camera, I'm going to give up my hobby.
No, man.
No, sir, don't do that. We like what you do.
Your images are amazing. I mean, yours are incredible. Those are unbelievable.
It's only for a few more years. Then that's it. Done.
Don't stop what you're doing, no, sir. We like what you do.
Yeah, don't stop what you're doing. Those are incredible.
Yeah. Just like digital photography killed photography.
It's about the tech, man. The tech curve's not going to stop. It's just going to keep going like this, just straight up. They're never going to stop. It's all that's done with, man. It's just going to keep going and keep going and keep going. And we're going to be playing catch up.
Okay, you guys can chat now. So you can chat after we're done. We'll probably leave the thing running for a while. So let's move on and get our last show and tell in. Then we can do the raffle, and then we'll have some time to ask questions of everyone and talk a little bit. So let's get to Mr. Nakamoto.
I can't see any of you. Can you hear me?
Yep.
Okay, we'll try it this way. These are just images from this year. Due to one thing after another, I really didn't get started till June.
We don't see anything yet.
Yeah, David, are you sharing?
I'm sharing.
We only see your name.
Don't-
Another screen?
Yeah, we don't
Wait,
see
wait, who else is sharing?
Nobody.
Nobody.
no one right yet. I turned mine off.
Dave, I don't think you have your video on at all.
There you go.
There you go.
Okay.
There you
See you
go.
now.
Doesn't matter if I have video on, you just need to see my screen.
That's nice.
Yeah.
Okay, this is, these are in chronological order. This one happens to be from Garvey Ranch Observatory. So we're dealing with a 4.7 inch f8.33 refractor and a ZWO camera. I'm not going to give too many specs other than that, because all this equipment is pretty much at Garvey is obsolete with the exception of our new mount, which doesn't show up because we barely got it and got it operational.
Just for reference, for people who don't know, when he's referencing Garvey Ranch Park, that is one of the facilities that is just a little bit east of downtown Los Angeles. So we are in the middle of the city in Monterey Park.
Yeah, and Vance and I, mainly Vance, has developed techniques to try and reduce the sky glow. These are single shot color images because that's all we have, and we don't have time to take multiple exposures on different filters. So this is basically, I'm showing off what you can do even with a single shot color. For some reason that didn't advance. There we go. I believe these are all the same image size. So this is about 1.5 degrees across. This is a little cropped. And yes, this was taken with the ZWO camera because the QHY camera is at such a high mag and our seeing at the site is so bad that we can't really take any images with our planetary camera. So but we can't take those of the moon.
Is the seeing always bad, or does it ever?
It pretty much is always bad.
Oh, okay.
So if you go there, I always assume it's going to be bad.
And by bad you mean 2 arc
I mean maybe 1-2 arc minute seeing.
Oh, wow.
Not second, minute.
Gotcha.
So we basically don't take. I have a few planetary images later, but those are exceptional.
Yeah, that's a great image for that kind of seeing.
Yep. We do get deep sky, but we also get effects. Notice this little guy right here. That's a light pollution effect. Because we have a aluminum dome that's not painted on the inside, and we got field lights to our west and parking lights to our east, and God knows what else up on the hill, which is fully developed with housing. We got light pollution issues up there, but at least I accept that and just continue on. These now were taken with my own equipment, 6-inch f4 Newtonian on a Skyview Pro mount with a G10 Orion camera. In fact, all the equipment's Orion except for the laptop. This is the spectacular NGC 253 in the southern part of the sky in the Galaxy Sculptor. This is my best image to date. I pretty much every time I took this at Borrego Springs at the annual Nightfall Star Party, which I try and regularly attend, because from my townhouse, I have absolutely positively no southern horizon. There's a line from southwest to northeast, and if it's north of that line, I can observe from my backyard. If it's not, I'm cooked. So I use this as an excuse to go south. That is one of many, that particular night, one of many star trails. I think I got photobombed by Starlink.
It's a great image for how south that object is from Garvey.
Yeah, I'm surprised.
It's amazing.
Also, it's and I'm going to echo Tim Russ what he said. Notice that exposure time right there, 60 seconds, 24 images, live stacked. which I'll explain one of these days, or if you go to my video about it on the LAAS site, that will explain it. But this is my best image to date. This is 46 and 47. You can identify 46 because of that planetary nebula, which has absolutely positively nothing to do with the cluster. But I just love these star. I like single shot because you can instantly get and enhance these star colors. This is a first time object for me, not this joker. That's just M52, just another cluster. There's the bubble nebula. I didn't think it was that bright, but it came in, it actually was visible with a 60-second image. But I figure with stacking, the noise goes down. So that some of these, that pixel right there, for instance, that's a hot pixel. You can always tell because it's not spread out. But the other ones, like that one obviously, when they're spread out, they're actual stars. Yes, I was using dark frames and but not flat fields. But even so, for some reason, I had sensor heating problems. But this one came out very nice. Triangulum, my best photo of this to date. The seeing, despite the fact that we had clouds moving in and out all 3 nights, the seeing was actually quite steady. A lot of the visual observers started seeing details and objects that normally they wouldn't because the light gets spread out due to seeing. The rosette, oh, I should mention, this field of view is slightly wider than what we get at Garvey Ranch. This is 1.7 degrees across by 1.3 degrees up and down. This was a very productive outing this year. This is my best photograph through any scope of this object. Lots of details in these dark lanes. That's how you could tell. First time for this one too. This is the elephant's trunk. Quite frankly, I don't see an elephant's trunk there, but I was just happy to acquire it. I later checked and all this red stuff around here is part of the complex, but the actual elephant's trunk is apparently this guy right there. There are probably several star clusters in here. I tried to identify them, but it's like totally hopeless when they're jamming up against one another. Any guesses? Andromeda, obviously. Caught this for the first time, and a lot of detail in here. This is one of my better images, if not the best of it. But 1.7 degree field of view, and of course that's this way, not this way, prompted me to take the view in the north. You could see a lot of detail in here, a lot of probably star clusters, since they don't look red. For instance, that's a star formation region similar to Orion, or I'm told.
Sharp as the.
And here are the Pleiades, still taken from Nightfall. Despite the fact that Nightfall is held at the Palm Canyon Resort, down through the years, the resort and the Riverside Telescope makers, RTMC directors, have worked with each other to make that a dark site. One of my friends, Don Penzak, measured it straight above 21. 21 Mac, that's plus 21, that's dark. So if the object passes overhead, you can grab a lot of detail. Again, this is, I've imaged this before, but not to this detail. Absolutely amazing. The Cone Nebula, which is just that portion right there. I've imaged this, we've tried to image this from Garvey, but it is just too faint considering our light pollution, which is horrendous. So again, just as Tim said, take your scope out to a dark site. You'll see a lot more. You'll shorten your exposures. You'll just have a fun time. The thing is, though, is that most of the time you're going to be in the city. This, I believe, is also Garvey Ranch. Not sure what these moons are or whose shadow that is, but every now and then the seeing does cooperate. And this was taken through the QHY camera. But I think the F ratio, I think Vance put a Barlow in there. So the F ratio is not 8.3. It's more like 3 times that. I don't know why Mars did that, but that was Mars on the same night. Unfortunately, that is also the view we got on occultation night. This is the boring half of Mars. There is a volcano right there, but it's basically not too many dark features. This was taken at Griffith. We finally opened up at Griffith. This is through my 7-inch Maksutov f15 and my next image, Celestron Next Image 10 camera. It shows what that combination can do. And yes, this is pretty much, this is also with a 2 times Barlow. So that's F30. And I got to show off the occultation, both sides. Everybody at Griffith missed when this thing started poking, when Mars started poking out. This is the soonest I could capture it. I believe that's the soonest everybody else could capture it. Yeah, it was more than halfway done. What can you do? I thought it was going to emerge. See where the cursor's going? Way up there. And then I noticed at the bottom of the frame, wait a minute, there's something bulging out there. And I realized I went too far north. But January 30th, we get a reprieve. We get another shot. 8:36 is when it ingresses, and 9:30 is when it egresses. So mark it. That's a Monday, by the way. And I don't know if Griffith's going to do anything or not, but certainly it's going to be very high in the sky, almost directly above us. So Garvey should be able to acquire it if we open up on a Monday. And I believe that's, no, not quite. Went ahead of myself. Okay, this is from Griffith. And this is a prime focus with the 7-inch Maksutov. So that's why it's relatively small. This is with 2 times Barlow from Griffith. And it's the best and probably my only image of Saturn from this year. And that's what Mars looked like. Once again, we got the boring face of Mars. We just got a few dark markings there. But we did catch I did catch a cirrus clouds from the North Polar region. The North Polar region is still, the South Polar region has evaporated. The North Polar region is still kind of sort of beyond the limb, but ice clouds are coming over it. And that's what we're seeing there. At least that's what I've been told. And I believe that's it. So I've operated with 3 different scopes, 3 different locations, actually 4 different locations now I think about it. And I do this to observe. I think this is just easier. Certainly it's easier for the public. And I get to record more or less precisely what it was I saw. And this is why image, which is why these exposure times were large only for Borrego Springs, because the lack of light pollution allowed me to push it to 60 seconds. Normally at Garvey Ranch, we're still limited to 30 seconds. And from Garvey, it's split seconds, of course, because the planets are so damn bright.
Dave, thanks a lot. That was really great. And thank you for your work at Garvey every week, doing the imaging, talking to people up in the dome.
Oh, yeah. Oh, and
really nice. Really appreciate it.
My pleasure. Really is. We're still going through a Planet Fest, by the way, folks. Going west to east, Saturn, Neptune, Jupiter, Uranus, and Mars. And they're all visible pretty much all night. The only thing we're waiting for is Mars to rise or get above whatever it is it's behind. Once that happens, we got all those planets available.
Fantastic.
And with the computerized scope, it's a lot easier to pick up Neptune and Uranus.
Thanks to all of our presenters. I think everyone was more interesting than next what it seemed like. So thank you all.
Hey Dave, could you put your face on the screen? I've never seen you except when it was dark and maybe only red illumination.
Who are you looking at?
Dave.
For
yeah,
some
knock 'em
reason,
out.
for some reason, Don wants, or Terry wants to look at my face. I can't imagine why. Besides, amateur astronomers identify each other by their voices. You never shine a light on somebody's face at a dark side break. It's like, oh, I heard you. No, we literally say, oh, I heard you the other night.
That's funny.
Just
That
like
does
that.
happen. That does happen.
Yeah.
Well, Spencer, should we move on to
Yeah,
the?
okay.
Move on to the.
Yeah, so I've
Sharing, by the way,
yeah.
I'm still sharing.
Go ahead. Yes.
I'm
Yeah,
sharing.
I'm
There we go.
All right. So I've posted the link. Let me repost it one more time. So that's the link for the raffle. So go ahead. I'll give you about 30 seconds and maybe 45 seconds. I'll give you a minute, okay, and I'll close it out, and then we'll harvest names.
David, what was the date of the next occultation at Mars?
January 30th. Ingress is 8:36. Egress is 9:30, and set up long before it happens, because I've timed out that video, which is where those two frames came from. 30 seconds to disappearance, 30 seconds to reappearance. It's quick. The moon moves very fast and Mars is very small. So don't dilly-dally. At Griffith, we actually set up 2 hours ahead of time and we track Mars. That's the safest thing to do. Just start tracking Mars, keep it going.
We could also announce that there's the next Griffith Star Party. I think we have a date for that. Dave Jacobson or Tim, what is it?
I think it's the 28th, January 28th.
Yeah.
Saturday night.
Is that correct? Tim?
Yeah, I think so. And it's a regular open star party, just like it has always been in the past. Anybody can come, no restrictions, set up whatever you want, just like the old days.
Right. So the Parks Department and the city have released all of their restrictions. So we're just kind of back to normal. So everyone can go up.
How does
bring their
parking
stuff.
work for that?
We will get a permit, and their crew up at the observatory will park you in a section of the parking lot that's basically reserved for us.
And so you do that ahead of time, or you just show up and say, I'm with the.
Yeah, you have to be able to show that you're with the LAAS.
Okay.
But they do.
In some way.
They want their flyer though, right? It's something that we have to get from them and send out.
Yes.
Yeah, you just need to show up.
You print that out and bring. You print that out and bring it. Your LAAS identification does not get you in. You need their flyer.
All right.
Yes.
Okay.
Yeah, you need to be there before you need to be there before 6 o'clock.
Okay.
PM to get
the parking.
Thank you.
Okay.
Okay. So I've closed out the drawing, and so I'm going to post the names here.
First winner.
Okay, hang on just a second.
First winner is
error message. Mr.
Yeah.
Error message.
Hang on. Hang on 1 second. Let me just. Okay, hang on 1 second. Let me just grab this now.
Error message always wins.
Yeah. Well, look, at least the screen didn't turn blue.
All right, so there's the first winner.
Ilya Heckerson.
Congratulations, Ilya.
Are you here?
I am. Thank you so much.
There he is.
You're one of our new members, all right?
I literally joined like a week ago. So,
well, welcome. We have a prize.
What a great introduction to the club.
You better go buy a lottery ticket.
Is Alicia here?
What did Ilya win?
I was trying to write his name down, but Spencer moved it.
Oh, sorry.
There we
You
go.
moved faster than I could write his name. Okay.
Alicia is the doler of prizes.
Okay.
What did
Ilya won an Amazon gift card for $25.
Awesome.
Okay.
Ilya, now you have to sign up for the Smiles program. So when you order from Amazon, we get a little trickle of money.
Indeed.
All
Indeed.
right. Next one is George.
George Azar.
Who we got?
Hey, George, I see you. I see your name. Are you still wake up now? George there? I see his name on the screen.
I don't know. Well, George won an LAS hat.
Okay.
Okay. All right.
He'll get it. Andrea Scarlett. Oh, there she is. Hi.
Thank you.
What are you getting?
Andrew won the Celestial Observer's map of the moon.
Sweet. Thank you. Awesome.
Okay. Curtis.
All
Yeah, I'm
right,
here.
Curtis. Yeah.
He's here.
What again? Okay. Okay. Curtis won a red flashlight.
Oh my God, Carol needs one.
Good. Perfect.
You always think
Yeah.
Curtis won just because his name shows up, but don't let Carol fool you.
Okay, next. Randy Canfield.
Woohoo, I'm here.
Cool.
Randy won an item from the LAS store.
Okay, so go to the website in the merchandise area.
All righty. Thank you much.
Okay, how many is that it or?
We have two more.
Okay.
Two?
Yeah.
Okay.
Let's see. Where is Randy? Let me take his name off of here. Oh, here we go.
There he is, 21.
Steve Cooperman.
Hey.
Hey,
Hi.
Steve. What do you get?
Steve won Northern Summer Sky and Astronomy Constellations etched 10-ounce tumbler gift set.
Thank you.
Wow.
The Constellations etched gift set with tumblers. Yeah, they're tumblers. They're really cool.
Okay, last one here? Yeah.
Yep.
Joe Phipps.
Joe Phipps.
Get in.
Yay, Joe.
Hey, Joe.
Yeah, Joe, give yourself a hat.
Thanks.
What did Joe win?
Joe won the Celestron Skymaster 15x70 astronomy binoculars.
Yay.
Oh.
Oh.
Cool.
Absolutely wonderful. Okay, well, that's the last prize. And we've had all the speakers. I want to thank everyone for coming. We had a really nice showing. I think at the beginning or in the middle, we had over 50 members here. So it's really nice to see everyone coming and joining in. We can stop the recording and streaming.